Hi there, folks. Today we're looking at solving systems of equations using things called matrices, okay? And matrices, that's just plural for the word matrix. So let's talk about those a little bit. A matrix is just a rectangular arrangement of numbers in rows and columns, all right? So again, plural is matrices. And this is used for a couple different things. If we look at this guy down here, here's an example of a matrix, all right? So we would call this matrix A. When we label a matrix, we define it in terms of its dimensions. And we always do rows and then columns. Remember, rows are the horizontal guy, columns are the vertical pieces. So this particular matrix, this would be a 3 by 2 matrix, all right? So matrix A would be a 3 by 2 matrix, and we could write that off to the side like this. Say matrix A is a 3 by 2 matrix. And if you're ever dealing with a graphing calculator where you're plugging a matrix in, or a computer program, you'll have to tell it what kind of matrix this is so it'll give you the right dimensions, that kind of thing. And these are used in a couple different ways. Sometimes they're just used to organize data. So like a 3 by 2 matrix, maybe I was polling my class on the certain activities that they do. So there's 3 activities that I'm looking at, and I want to break the data down into, freshmen and sophomores. I could display that in a matrix. So the columns would be broken down by freshmen and sophomores, and then the rows would be broken down by those 3 activities I was talking about. It's just a nice organized way to display those numbers. And then if I pulled another class, I could do a separate matrix for them. So I could keep all those values separated, but then it would be also easy to combine them to get totals, all right? So that's one thing that a matrix is used for, is simply just displaying data and data collection, those kind of things, all right? One of the things that we use it for in algebra and in higher level mathematics is we use them to solve equations. And to do this, we essentially use this thing called an augmented matrix, all right? So instead of having a standard matrix, we kind of shift it over just a little bit to include the solutions, all right? For example, if I look at something like this linear system of equations, ax plus by equals e, and then cx plus dy equals f. And in a real situation where we were solving a system of equations, we'd have numbers plugged in for all those things, all right? But this translates into an augmented matrix that looks like this. Basically, I'm still breaking this thing down in a kind of an organized fashion where this is the values for my x, my coefficients for x. This is my coefficients for y. And this would be like equation 1, and this would be equation 2. So we're just kind of organizing. This last row over here is where we put what each of these is equal to. All right. So one of the things about an augmented matrix, if we want to write an augmented matrix using a system of equations, the system of equations has to be in standard form. It has to be, the x, y equals constant kind of format. The other thing is I put a little bar in here. Some textbooks will do that. Others will write this without the little bar. You'll just see it written like this. Okay. So without the little bar in there, I always stick that in there, especially when I'm working by hand, to remind myself of where the equal sign is. It's just a nice way to keep things straight. You do not have to have that bar in there. Most textbooks that I've seen recently don't have that bar in there. So put it in there or don't put it in there, it doesn't matter, okay? Something like this, the identity matrix, and really when we're solving a system of equations using matrices, we're going to start with a matrix, an augmented matrix that represents the system. Our goal is to get to this thing called the identity matrix. And again, the reason for that is because as I look at this thing, this is broken down by x, y, and then this would be equation 1 and equation 2. So if you translate that back into an equation format, this first equation is just saying, hey, 1x without any y's equals a, so x equals a. The second line of this thing is saying that no x's plus 1y equals b. In other words, y equals b. See, when we get to the identity matrix, it's essentially the solution to our system of equations if we kind of rewrite it back as a system. All right. And so that's kind of going to be the idea here is we want to start with a system of equations. We're going to write it as an augmented matrix. And then we're going to convert that augmented matrix. We're going to manipulate that matrix to get the identity matrix. All right. And essentially what we'll have done then is solve the system of equations. All right. And basically, I like to kind of think of this almost like playing a little bit of a game. And so here's the rules to the game. I'm going to start with an augmented matrix, and here's what I'm allowed to do to it in order to try to transform it into the identity matrix. Okay? I'm allowed to multiply or divide rows, so I could replace the first row with that same row but multiplied by 2. Okay? Or I could replace that same row with that row divided by 2. All right? And so I can replace a row with multiplication or division of a row. All right? That's one thing I'm allowed to do. I can replace a row with addition of or subtraction of 2 rows. So let's say instead of that first row, that first line that I have, I want to replace that with the 2 lines being added together. I can do that. So I can add the 2 rows together and then replace one of the rows with that sum or difference if I did subtraction. Okay, I'm allowed to switch rows. So if I don't like the position of the 2 rows, I can switch row 1 and row 2. All right. And then this becomes a little more complicated because we can do combination of these rules at the same time. So if I wanted to multiply a row by 2 and add that to the second row, I can do that all in one shot. I can use a combination of these rules at once. Okay? And as you look at these rules, students start to get a little bit confused and they're like, that seems like a little bit much. You've already used these rules. All right? These are the same rules that apply to solving systems of equations using elimination. All right, it's the same rules. With elimination, I'm allowed to multiply a row by something. I'm allowed to, multiply one of the equations by something, or both of the equations by something. I'm allowed to divide the equations. I'm allowed to add the equations together. That's the whole point of solving by elimination. All right, so those kind of things. So it's the same rules, but we're kind of just not writing down the variables at this point. Okay, and that seems strange at first, and it'll feel a little bit odd when we do a system of 2 equations, 2 variables, but this becomes very useful as we get bigger and bigger systems of equations. Okay, so it's the same rules for elimination. We're just applying them to these rows of numbers, all right, that represent our equations instead of multiplying equations themselves. Okay, for example, so if I look at this one, so this is a system of equations, and you could solve this system by substitution or elimination. I'm going to write it as an augmented matrix. So I've got, let's see, 2, 1 equals 6. 1, 3 equals a negative 2. I put my little brackets around this thing. And again, I'm going to include the line here so I can see that's my equal sign. And the idea, once again, is I want to transform the matrix that I have into this matrix, okay, the identity matrix. All right? And again, I'm only looking at that left side. I want to turn that left side into that. Whatever happens on the right-hand side, those will be my solutions eventually, okay? And so I think about my rules. And the way I approach this is I always start in that top left-hand corner, and I do a column at a time. So I want to turn that top left-hand corner into a 1, and then next I'll try to get the thing underneath it to be a 0. And then next I'll move on to the next row, okay? Or the next column. So for example, if I look at this one, a really easy way to turn that top corner into a 1, when you look, I already have a 1 right here, okay? I just need that 1 to be at the top instead of at the bottom. Remember, one of the rules I have is that I can switch the 2 rows. So that's what I'm going to do. I'm going to switch the 2 rows. So I'm going to switch the rows. And so I'm already well on my way to turning this into the identity matrix. And a lot of times what we'll do in order to kind of just document our work is I'll just say what I did. I'll say, hey, I took the first row and the second row and I swapped them, okay? And I just use little descriptions like this, R1 for the first row and R2 for the second row. And I used the little arrows to show, hey, I switched them, okay? Now from here, I want to turn that spot that has the 2, I want to turn that into a 0, okay? And remember, I'm allowed to add or subtract the 2 rows. So maybe I would do something like, well, let's subtract the first row from it, okay? And I could do more than that, but I'm just going to get myself a little bit closer. So I'm going to leave that first row the way it is, okay? I'm happy with that one for right now. But now I'm just going to subtract the 2 rows in order to transform that second row a little bit. In other words, I'm going to take this second row and I'm going to replace it. I'm going to turn it into the second row minus the first row. I'm just going to subtract the 2 rows and see kind of where that gets me, all right? And if I do that, 2 minus 1 is a 1. 1 minus 3 is a negative 2. And 6 minus a negative 2 is a positive 4. Okay? And here's the thing. I didn't turn that into a 0, but I got closer. And you can see that if I subtracted it again, if I did the same thing a second time, I would end up with a 0. So I'm going to take row 2, and I'm going to do the same thing again. I'm going to do row 2 minus row 1. Okay? And if I do that, again, I'm leaving row 1 the way it is. I just want to change row 2 right now. 1 minus 1 is a 0. Negative 2 minus 3 is a negative 5. 4 minus a negative 2 is a positive 6. Okay? Oh, sorry, that one should have been an 8. I made a mistake here. 6 minus a negative 2 is an 8. See, I made a sign error. And now when I subtract those, I actually get a 10. All right? And so now from here, I have the 1, I have the 0. Now I'm going to move on to the next row. The next row, I'm going to try to turn this guy, and I always start with the position of 1. So if I look at this guy, I want to turn that guy into a 1. All right? So I don't necessarily work my way down the column, but I work on the first column first. I get the 1 and then the 0. Now I go on to the next column. I want to get the 1 and then the 0. And it just so happens the 1 has to be in the second position this time. And so as I look at that equation, this is a really easy one to do. I can just divide that second row by negative 5. See, if I take that second row, I can just replace it with that thing divided by a negative 5. And so if I divide that second row by negative 5, again, I leave the first row the way it is. If I divide this by negative 5, that gives me a 1. 10 divided by negative 5 is a negative 2. Okay? So now I got the 1 and the 0 in the first row, or the first column. The second column, I've got the 1. Now I need to get the 0. And I'm going to backtrack here to one of these second two steps. If I look at these second two steps, this step right here and this step right here, where I subtracted that row and then did it again, I could have done that all in one step. Okay? And here's what that would have looked like. Instead of doing this twice, I could have said, hey, I'm going to turn R2 into R2 minus 2 of the first row. Okay? Instead of subtracting the first row twice in 2 steps, I could have done it in 1 step. And see, that would have brought me right to this guy. So I could have cut this step out had I done the thing in purple. And I mention that because we can gonna do the same thing here. So let me try this. Let me attempt the same thing here. If I want to turn that 3 into a 0, I would have to subtract 3 of that second row. In other words, I'm going to take R1 and I'm going to replace it. I'm going to do R1 minus 3 of that second row. Okay? And again, I could just subtract the second row and then do it again and then do it again until I ended up with a 0, but I can kind of condense that into one step. Ready? So right here, 1 minus 3 zeros, and again, the second row stays the same. I'm not changing that one. But 1 minus 3 zeros is still a 1. 3 minus 3 of those 1s is a 0. And then negative 2 minus 3 negative 2s, it almost looks like this. Negative 2 minus 3 negative 2s, okay? That's negative 2 plus 6, which is a 4, okay? And that's it, I'm done. I have the identity matrix, and this translates into my answer of x equaling a 4 and y equaling a negative 2. And again, you could have solved this system of equations by simply doing substitution or elimination. This is still elimination, but it's in just a different format. And you're probably looking at this thing going, that's not any easier than elimination. And I would agree with you, okay? But as we get to larger and larger matrices, this makes more sense, okay? When you think about all the work we went through trying to solve a system of 3 equations and 3 variables using elimination, there's a lot going on. It creates a mess, okay? And so what this does is it kind of declutters our work a little bit. It makes this easier, okay? If you think about a system of maybe 4 equations and 4 variables, this becomes much easier than elimination in the traditional sense because of the kind of the streamline that it goes through, not writing the variables and that kind of stuff, okay? For example, again, let's do another simple one here. Before we move on, let me write this as a, why I'm running the plus sign like a crazy person. Let me write this as an augmented matrix. And again, I'm going to include the little bar just to help keep myself a little bit organized. But from here, I want to turn that top corner into a 1. And as I look at these equations, I could turn the 2 into a 1 pretty easily, so maybe I'll do that, all right? Because remember, I'll be able to switch the rows then. So I'm going to take row 2, and I'm going to turn that 2 into a 1 by just taking it and dividing that second row by 2, okay? And again, I'm just listing my work. I'm explaining my work underneath by doing that little notation. So if I divide that second row by 2, I get 1, -2, and a -5. And now if I want that 1 to be in the top row, I just have to switch them, okay? So I'm going to switch the 2 rows. Row 1 and row 2 are going to switch. I flip them around. Okay. And now my next goal, I've got the 1 in the first column. I need to get the 0 in the first column. So I need to turn that 8 into a 0. And anytime we want to get a 0 here, this is where we use that addition and subtraction of rows. If you didn't realize that the last time, that's how we got the zeros. It was adding or subtracting rows together. So this one, if I want to turn that 8 into a 0, so I want to take that second row, I got to take that 8 and I have to subtract 8 of the first row. So 8 of row 1, okay? And so again, it just takes a little bit of mental math, and you could take it off to the side if you need to. What's typically very helpful, if you're subtracting 8 of the first row, think about what 8 times this first row is. It would be an 8, a -16, and a -40, okay, if I multiplied that first row by 8, all right? So now subtract 8 minus 8 is a 0, which is what I want. 5 minus 16 is a 21. 2 minus a -40 is a 42. And so that's what that looks like. And, you know, some of us can do that in our heads. Others are just going to have to write down what 8 of the first row is. It makes it a little bit easier, okay? So now I've got the 1, I've got the 0. I move on to the next column. Again, I start with the 1 in the next column. I need a 1 where that 21 is, okay? And if I look at that row, I should notice right away that, hey, that whole row is divisible by 21. So row 2, I'm going to take and divide it by 21. And when I do that, it's going to give me the 1 that I needed. Let's see, 0, 1, and that's a 2. Okay? And so again, I kind of systematically go through this. First column, get the 1, then get the 0. Now I go to the next column, I've got the 1, I have to get the 0. And if you look, I can get that -2 to become a 0 if I add 2 of the second row. Okay? See, now I'm trying to transform this first row. I want to turn that -2 into a 0. And I can do that by taking that row and adding 2 of the second row. And so once again, if you need to write down what 2 of that second row is, multiply that entire second row by 2 and write it off to the side. 0, 2, and 4. Okay? So now if I add those values to the first row, here's what I get. Sorry, I switched colors on us. So 1 plus 0 is a, sorry, let me write down the second row first. 1 plus 0 is a 0. Is a 1. Oh boy. Get your head in the game, Mr. Jansen. -2 plus 2 is a 0. And then -5 plus 4 is a -1. And so now I have the identity matrix. This is interpreted as x equals a -1 and y equals a +2. Okay? Again, I'm using the same rules as elimination, but I'm doing it in a little bit of a different format. Okay? All right, if I look at the next one, now we're going to do one of these complicated ones. All right, so we're going to do a system of 3 equations and 3 variables. It's the same kind of deal. Here's what the augmented matrix would look like. All right, makes sense. I'm just writing the things down. The identity matrix this time, notice it looks kind of the same, but we've expanded it a little bit. So we have another 1 and another column that has zeros filled in. Okay, and if you look at like the top corner of this thing, this is the first identity matrix we had. So we're just kind of expanding it diagonally. All right, if we had 4 equations and 4 variables, we'd have another column and another row, and we'd have a 1 down in that corner. So we would just keep expanding that 1 diagonally and filling in the zeros. Okay, so that's the goal. That's what we want to get to. So let's see what this looks like. So I start with the matrix, and I write it down. And be careful with this last matrix. Notice it's missing the y value, so the y value is a 0. So I'm going to put a 0 there. Okay. And so I have my matrix written down. I want to start in that first column. I want to get a 1 at the top, which I already have. So now I want to work my way down and get zeros for everything else. All right. And you don't necessarily have to take that approach. I just think that systematic approach is the easiest thing to do. Okay. So I already have a 1 where I need it. So now I'm looking at this second one right here. I want to turn that guy into a 0. All right. And so to turn that into a 0, I can simply subtract the first row. So if I take this second row, and I'm going to replace it with that row minus the first row. Okay, so I'm going to subtract the 2 rows. That'll give me a 0 there. And notice the only row that I'm changing, I only change 1 row at a time. The only row that I'm going to change this time is the second row. So 1 minus 1 is a 0. 1 minus 2 is a -1. 1 minus 1 is a 0. 3 minus 9 is a -6. Okay. Again, we can put the little bar in here to kind of keep that separated if you would like. So now I'm working my way down. I have to turn that 5 into a 0 now. And to turn that 5 into a 0, so now we're talking about the third row, I would have to take that third row and I would have to subtract 5 of the first row. Okay? So that's what I'm going to do. I'm going to subtract 5 of the first row. So once again, the only row I'm changing this time is the third row, so everything else can stay the same. And so if I subtract 5 of the first row, and if you need to write down what 5 of the first row is 5, 10, 5, and 45. Okay? And now subtract. 5 minus 5 is a 0. 0 minus 10 is a -10. -2 minus 5 is a -7. And then -1 minus 45 is a -46. Okay? So now that first column is done, I move on to the second column. I have to get the 1 in the right place. And so it's that middle row. I have a -1 right there right now. I want to turn that into a +1. So I'm just going to take that second row, and I'm going to multiply it by a -1 or divide by -1. And again, it's not like I have to write that down. I'm sure you could probably do that step without writing down that justification, but it's a 1, a 0, and a 6. And then here, this guy stays the same. Again, there's lots of ways to do this. This isn't even necessarily the easiest way, the way I'm doing it right now. But that consistency is really helpful a lot of times when students are doing these. Okay? So now I have the 1 in place. I have to turn that top row, that 2, into a 0. Oh, sorry, row 1. I want to turn that into a 0. So all I have to do to turn that into a 0 is I have to subtract 2 of the second row. Okay? And so when I do that, let's try doing it in our heads this time, see how it goes. Again, these guys stay the same. And it's just a fun little game that we're playing, trying to turn these into the right thing. So let's see, 1 minus 2 zeros is still a 1. 2 minus the 2 ones is a 0. 1 minus 2 zeros is a 1. 9 minus 2 sixes, so 9 minus 12 is a -3. Okay? And I'm going to end up crossing out this next example so that we have more space to keep working here. So I've got the first 0 I needed. Now I need to turn that -10 into a 0. To do that, I'm going to take row 3, and to it I'm going to add 10 of the second row, 10 row 2s. Okay? So again, the first row doesn't change. The second row does not change. I'm only changing the third row. And so 0 minus 10 zeros is a 0. -10 plus 10 ones is a 0. -7 plus 10 zeros is still a -7. And then negative 46 plus 10 sixes, so negative 46 plus 60 gives me a positive 14. Okay? And so now I move on to the last column. The first thing I want to do is get my 1 in place, so I want to turn that negative 7 into a 1. And I can do that by dividing by negative 7. So row 3, I'm just going to divide it. R, oh boy. I'm just going to take it and divide it by negative 7. And what happens, you start to get really good at these, and you can kind of do more than one step at a time, and there's all kinds of stuff that can happen here. Let's see, that's going to be a 1 and a negative 2. And now I got to get my zeros. I already have one of the zeros I need. I just need a 0 in that top equation. So to do that, I'm going to take that first row, and I'm going to subtract the third row. Okay? So here it is. These rows do not change. But the top row, if I subtract the third row, I get 1, 0. Here I get a 0. And then negative 3 minus a negative 2 is a negative 1. And that's it. Here's my answer. X equals a negative 1, Y equals a 6, and Z equals a negative 2. Okay? And as we look at that particular example, you might be looking at going, that's maybe a little more work or about the same amount of work as doing elimination. By the time we get to 4 equations, 4 variables, this thing becomes really useful because it really cuts down on the confusion and all the stuff that we're writing. Okay, it streamlines the process. So the more equations and the more variables you have, the better this method becomes. Okay?